So today we're going to be working more with scatter plots, but figuring out ways that we can have our calculator do the majority of the work for us instead of us doing it all like we did manually yesterday. So yesterday when we were working with scatter plots, you guys had to physically graph the scatter plot and then physically calculate the line of best fit. Your calculator can actually do all of that for you. So using the same set of data that we had from yesterday, we're going to have our calculator graph the scatter plot for us. So for part A, it says enter the data into lists on your calculator and create a scatter plot using your graphing technology. So just like you used to do, we're going to go into Stat and Edit and pull up our table. So I already have all the data points in there. So you can pause the video now and enter all those points in, your X values for L1, your Y values for L2, making sure they match up along the way. If you have values already in L1 and L2, go up to L1, press clear and enter, do not delete. If you have values in L2, go over to L2, press clear and enter. Again, do not delete because it will get rid of the whole column and then you have to work to figure that out, how to put that back. Right? So while you're entering, you want to pause. I'm going to walk you through now how to actually create the scatter plot. So if you're at the point now where you're creating the scatter plot, we're going to go to y equals and make sure our plot one is highlighted. We're going to go to window and we're going to set up our window so we only see the first quadrant. So if you're looking at low temperatures, you see a low temperature here of 26 and a high temperature of 45. So I've made my X min 0 and my X max 50 because that will be able to see all the numbers in our low temperature. Then go down to Y min, and I'm going to scale it from 0 to 80 because, again, our high values don't have anything lower than 0 or higher than 72. So 0 to 80 will show us that part as well. And then I'm going to press graph. And in my graph, you can see the scatter plot, which looks pretty similar to the scatter plot that you created yesterday. So for part A, we're comparing. The two graphs are similar. So then we're going to use our calculator to find the actual equation for the line of best fit. It says to round the slope of the line to the nearest hundredth and the y-intercept to the nearest integer, and compare this to the slope you found in the last lesson. So here again, now to find the line of best fit, I've already got all those points in my calculator. We're going to go to Stat. We're going to go over to Calc. And we're going to pick lin reg because that's going to give us a linear function, ax plus b. Underneath that, you see quad reg, that's for quadratic functions. You see cubic reg, that's for cubic functions. And further down, you see exp reg, that's for exponential functions. So we can use those as well, and you'll see more of that later this week. But choosing choice 4, we can press 4 and then enter. And you're going to enter all the way down. We want our X list to be L1, our Y list to be L2. So if that's not there, you got to make sure you fix it. And then go to enter, 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 enter. And it gives us an A value and a B value. So again, they wanted us to round our A value or slope to the nearest hundredth. So we have Y equals 1.16x, and then our y-intercept to the nearest integer, so that's going to be about 19. So we have 1.16x plus 19. And then we want to compare this to the slope we found in the last lesson. So if you remember yesterday's lesson, we had a slope of 6/5, and 6 divided by 5 is 1.2, which is really close to 1.116. And we had a y-intercept of 18, also really close to 19. So they're only a few points off. The slope is only 0.04 of a point off, and the y-intercept is 1 off from what we found yesterday when we were estimating. So now the next part says, explain what the y-intercept of this model represents in terms of the low and high temperatures that are being modeled in the problem. So again, it was y equals 1.16x plus 19. Our y-intercept is 19, so that means that when a low of 0 is predicted, we can expect a high of 19 degrees Fahrenheit. Okay, so the y-intercept just tells you what the y would be in relationship to the x at 0. Then D, how would you interpret the slope of this model in terms of how the low and high temperatures change with respect to each other? So remember, slope is change in y over change in x. So our slope is 1.16, which is 1 in 16 hundredths. I'm going to simplify that a little bit further. So that's 1 and 4/25. Rewriting that as an improper fraction, 25 times 1 plus 4 is 29 over 25. I like to write it this way when I'm talking about slope. I think it's easier to explain. So we could say as the high temperature increases by 29, the low increases by 25. You could also use the 1.6 and just say that as the high temperature increases by 1 and 16 hundredths, the low temperature increases by 1. But I like the idea of writing it as an improper fraction and then explaining the change in y over the change in x. All right, so you're going to go through this whole process again on the back side of your notes with a different set of numbers. I want to also show you that now that we've ran our lin reg, if we go to graph it, that line should also show up in the graph. Please work, please work. Oh, it didn't work. But if I go to my y equals now and put that equation in, we have 1.16x plus 19 and graph it. Now press graph. Look at that. The line of best fit goes right through the points. So you can use that graphing feature a lot to help you out as well. All right, you're on your own. I'll be around to help you out.